Today I am talking about normalization in a very detail. So what is normalization in databases? Normalization is the process of organizing data in database. This includes creating tables and establishing relationships between those tables according to the rules designed both to protect the data and to make the database more flexible by eliminating redundancy and inconsistent dependencies. In short, we can say it is organizing data in more useful way. Normalization increase the efficiency of queries, or we can say for developer it become easier to retrieve a data from table using queries. So there are few normal forms. The first is a zero normal form. Here you must have a table with the data. First normal form. In first normal form, the system first must be in a zero normal form. This means this table must have data. Remember that without data, we cannot identify the dependencies between the attributes. This means identifying the dependencies in attributes is necessary before normalization. And for identifying the dependencies, we must have a data. This means the system, the database or the table must be in the zero normal form. Then no multi-value complex attribute is allowed. This means if the attribute have multiple values, so we will then eliminate multiple values in first normal form. Or we can say the system should have the primary key. This means these are the few characteristics which must be obeyed. In second normal form, the system must be first in first normal form. This means the primary key must be identified, and all non-prime attributes must be fully dependent, functionally dependent on a whole primary key. Remember, whole primary key. So what are the prime and non-prime attributes? It is already covered in our last lecture. Prime attribute, non-prime attributes are those which are not prime, and prime attribute are those attributes which are part of the primary key. So if the primary keys consist of only one attribute, this means that attribute is a prime attribute. But if primary key is consist of composite attributes, more than one attributes, so that attributes will be prime attributes while the rest will be all non-prime. This means all of the non-prime must be fully functional dependent on a whole primary key. For example, if we have four attributes A, B, C and D, and the primary key is on the AB composite attributes, so this means C will depend on AB, not on either A or B individually but whole AB. And similarly D will also depend on whole AB, means D will not depend on the either B or A, but it must depend on the whole primary key. Or we can say no partial dependency. If in other, it is the definition, it is the similar definition that if the attribute is not fully dependent on a whole primary key but some of the attributes of the primary key, this means partial dependency exists. So this means no partial dependency between the non-prime attribute and the primary key is allowed. Now the system will be in the third normal form if all non-prime attribute must be directly functional dependent on the primary key and no transitive dependency is allowed in the table between non-prime attributes. Remember, non-prime attributes and the primary key. This means if there is transitive dependencies, what is transitive dependency? It is already covered in our last lecture. For example, B depend on A and C depend on B. So this means A identify B and B identify C. So this means there is transitive dependency between A and C. So we must have to eliminate this. So for third normal form, it is necessary that we must have to remove first the transitive dependency, or we should have to remove or eliminate the transitive dependencies. Let's come to discuss the three normal form on example. For example, this is a scenario where we have given a table. In this table, you can see R is the table or relation which composed of 5 attributes: item, color, price, text or quantity. If you see the column color, we have two values, red comma blue. This means this is multi-value. All of these value against the column color are multi-value. This means this table is in zero normal form because data is here, but it is not in the first normal form because of the repetition of the multiple values. Plus, we don't know yet what is the primary key for this table. So in order to convert this schema, this relation schema into first normal form, first we must have to eliminate the multi-values and then we should identify the primary key. So this is the first step where the multi-values are converted into multiple rows. So for t-shirt, we have now taken the two rows which contain the color red as well as blue. The rest of the values are same. For example, for red the price, text and quantity are same, which is this 5,3 shows 5 is the quantity for red and 3 is the quantity for blue. This means for red color we have taken the quantity 5 and for blue color the quantity are 3. So in this way we have eliminated the multiple values and converted it into multiple rows. Now to identify the primary key, we need to identify the candidate key, and for candidate key we need to identify the super key, which is already covered in our last lecture. And for super key we must have to identify all the dependencies. So from this data we can easily identify all the dependency. How? You can see t-shirt. If the item is t-shirt, then the price is 12. It is t-shirt 12, t-shirt 12. This means item is identifying the price, or price is dependent directly on the item. And if we know the price, we know we can easily identify the text. If it is 12, it is text is 0.6. See, for the price 12, the text is always 0.6. This means price identify the text, but the quantity depend on both item and color. How? For example, if we take only item t-shirt, which is the quantity is 5, but here in this case, the in blue color case, the quantity are 3. So this means item individually is not enough to identify the quantity. It also depend on color. Similarly, color individually is not enough, because blue is 3 and blue here is 12. So blue is not identifying the quantity. This means item and color combinedly identify the quantity. T-shirt red 5, T-shirt blue 3, T-shirt black 9, smart shirt sweet shirt black 2, sweet shirt blue 12. So these are the all possible dependencies. If we take the closure of item will become item, price and text. The closure is covered in or how we can calculate the whole closure of the attributes or combined attributes. It is covered in our previous lecture. So item is not enough to identify all attribute. It identify item, price and indirectly then text. But item and color combinedly identify item. If we take the closure of the item and color, this is the closure, a plus sign above the bracket. This means item identify item, price, text and color identify the quantity. So item and color combinedly identify item and color, and then item identify price, price identify text, and then color identify quantity. This means item and color identify the whole attribute. This means the candidate key for the primary key will be the item and color. Remember, candidate key can be many. For example, in this relation there is only one candidate key, but in some other example, if we consider other example, the candidate key can be several, but we will then select only one candidate key as a primary. That is a choice up to you. So the primary key is default candidate key. Now the relation R1 will become item, color, price, text and quantity. Now this relation is in the first normal form. So we have eliminated the multi values, and then we have identified the primary key which is on item and color. So these are underlined. So R1 is now in the first normal form. The prime attribute will be item and color, while the non-prime attribute will be price, text and quantity. So these three are the non-prime attribute. Now look towards either this relationship is in second normal form or not. You will think, but for me it is not in second normal form. Why? Because of the partial dependency. Price depend on item, text depend on item, text depend on price, but indirectly text depend on item, quantity depend on color. So these non-prime attribute does not depend wholly on the one whole primary key. So this means we have to split this relation into further relations. How? See, item, price, text. This is the relation 2 and now relation 2 and 3, relation 1 is no more relation. Now relation 1 is replaced with two further relation 2 and 3. The first relation is item, price and tax. Remember one thing, if we left here the table, this one table with this relation, this is not incorrect. This is not incorrect. But this is in first normal form. The primary key is here on the item and color. Combinedly on item and color, the data is okay, the relation is okay, but we can say it is in first normal form. The data is not consistent, partial dependencies exist. So the query efficiencies will be not good. So the first relation will become item, price and tax. Here tax depend on price depend on item. So this means tax also depend on item, and quantity depend on the item and color together. This means item does not depend on a single attribute of this. So the table is now shown here. Two tables are now constructed from that previous single table, that is item, price and tax, item, color and quantity. This depend on these two, and this depend on item. So these two relations are now in the second normal form. Now think that this relation is in third normal form or not. This is not in third normal form. Why? Because transitive dependency exists. Partial dependency among the non-prime attributes and the primary attribute does not exist, but the non-transitive dependency in the transitive dependency in the non-prime attribute exists. How? Tax depend on price. So further two relation will be R2 will be replaced with two more relation. This means R3 will be replaced with R4 and 5. First relation will contain item and price, and second relation, which is R5, contain price and tax. Tax depend on price depend on item. Remember one thing, primary key is only on the item and item color together. Primary key is not on the price, but and price is also not a prime attribute because it is not a part of the primary key, but price attribute is a part of the super key. What is super key? All those attributes which define other attribute. That is not necessary, that cannot be necessary the primary key attribute, but that must identify other attributes. So that is already covered in our last lecture. So the three relations will become R3, which contain item, color and quantity, and two relation from R4 and 5 from R2, which contain item, price and price tax. So now three tables you can see. This is now in third normal form. There is another normal form which is B, C and F, but we left it for the next lecture. Now see another example. R is defined over A, B, C, D, E, F, G, H, I, J, K, L, M, and these are the relations given. Remember, if it is asked from you in exam, the teacher or examiner can directly give you these relations or can directly give you a table as you saw in the last lecture. But here the relations are directly given, which shows A identify CE, B identify DF, AB identify G, G identify BI, AG identify H, AJ identify K, C identify L. So in order to bring, remember one thing, if the relations are given, this means it is in zero normal form, because data exists, and from data we have identified, either directly we have written these or indirectly from data. But if the relations are given, this means it is in zero normal form, but it is not in first normal form, because we don't know the unique identifier primary key attributes. So how to identify the primary key? That is covered in our last lecture by taking the closure of each attribute and then the composite attribute. How? First we will take the closure of each attribute. A identify ACE. This means A cannot be the primary key because A will identify ACE. B identify DF. So we now take the composite attribute closure AJ, A with J, A with B, A with G, A with C. So by watching the last lecture, you will be able to find this candidate key. So this means the candidate key will be A, J, B, which are the minimum attribute. Remember, if we know the minimum attributes, we don't need to take the higher number of attribute. For example, if A, J, B identify all attribute, this means this is the candidate key. So if we take A, J, B with G, A, J, B with C, so this means that will also become the super key, but we don't need here to find a super key. So two candidate keys are here with us, AJB, AJG. Now in this example, AJB is selected as a primary. The choice is to you. You can select any of these two. So we will write a relation in this way. Here A, B, J variables are underlined. This means A, B, J combinedly as a composite attribute identify all these relations. This is now in the first normal form. Now think that this relation is in second normal form or not. This is not in the second normal form, because there exist a lot of partial dependencies. How? C, for example, if we see here A identify C, this means A identify C and A also identify E. That is the union property applied. A identify C and A identify E, this means A identify both C. So C is identified by A, not all the attributes. This means A, B, J. C is not dependent on A, B, J as a whole primary key, but it depends partially on A. Similarly, D and F depend on B. Here you can see from dependency. G depend on AB. Remember one thing, I have already explained this, that this relation is not wrong. If you left it here, this is okay, this is correct, but there will be only one table constructed. But the purpose of normalization is to organize data in more useful way and in more consistent way, so that the query efficiency improve. and understanding the data become also easier. So now in second normal form, we will eliminate the partial dependencies. This scenario is not easy. It contains a lot of variables and relations. So here you can see I have solved. How to solve this? The easy way is to take the closure of the primary key attributes. We don't need to take the closure of all attributes. That was just for initially for candidate key or primary key. Now we will take the closure of first individual attributes. Why? So that we can identify all possible relations where the non-prime attribute depend on the whole one primary key or prime attribute. So the prime attributes are A, B, J. Prime attributes are A, B, J. So we will first take individually the closure of A, B and J. The closure of A will become A, C, E, L. How? Identify A, that is the reflexivity property as covered in the last lecture in detail. Identify C, which is given, and C identify L. So this means the closure of A will become A, C, E, L. The closure of J is only J, and the closure of B is B, which is reflexivity property, and DF. So closure of B will become BDF. Similarly, we will combine the two attributes AB, JB, and AJ. So the closure of AJ is AJ, A is C, so C is L, so CEL, and then A and J here it is given is K. So the closure of AJ will become AJCELK. But the three variables C, E, L are crossed here. Why? Because A is already identifying A, C. Remember one thing, that we are now constructing relations. This means the relation 1, 2, 3, 4, 5, 6. We have constructed 6 relations. So A is already identifying CL in this relation R2. Here we have taken it as R2. So there is no need. We must have to eliminate this redundancy. C, E, L are already covered, but K is not covered here, so we are left K here. A is also covered, but here AJ comes again, so we were left AJ. Now the closure of AB will become A, B, C, E, L, D, F, G, H, I. How you can solve? AB will become AB, and then B will become DF. AB will become DF, so it will become AB, DF here. A will become CEL, so AB, CEL, DF, and G, H, I. AB identify G, so it will G, then AG identify H, and then so we will now cross CELY. It is covered in above closure. F is also covered here. Here B is identified already, F here, so we don't need to write here. GHI is not covered here, so we are left it here. Similarly, we repeat this process for this. Now one relation will be R2. Remember one thing, that R1 is no more. R1 is now replaced with these 5 relations. First relation is R2. ACEL. A is a prime attribute. This means the primary key of this relation will be now. Again I am saying, remember that this R1 is no more. It is replaced with these 5 relations. A is identified as CEL. Now these CEL are the non-prime attributes, and these all depend directly on a one primary key, that is A. In this relation, CL depend on A, but that was the first normal form. This means there is no partial dependency. DF depend on B, DF depend on B, K depend on AJ. So this is AJ. The primary, these are prime attributes. This means the primary key will be on AJ and K depend on AJ. And here GHI depend on AB. Here it is solved. G depend on AB. You can see G depend on AB here in a given scenario. Similarly, the closure of AB will become ABG, and then AG identify K. So this means indirectly H also depend on AB. And here G identify BI. This means G identify B as well as I. So this means I will AB is identify G and G is identify B as well as I. So this means AB is identifying I. So AB is identify AB as well as G and as well as I. And then AG inside this closure identify H. So there is no partial dependency. This G depend on whole AB, H depend on AB, and I depend on AB. Similarly, the sixth relation will become AJB. This means M depend on all of these three. You can see it is given in the relation AJB, and primary key is also on this AJB. So AJB identify M. So this is now in the second normal form. Now see, this scenario is in the third normal form or not. Obviously it is not in third normal form because there are a lot of transitive dependencies. See next page. These are the relations. A identifies C. Look at A identifies C and C identifies L. A identifies CE and C identifies L. This means there is a transitive dependency. Although A identifies C and C identifies L, this means A identifies both C and L. This also means C and L non-prime attribute depend wholly on one primary key. But this is the transitive dependency or indirectly dependency of non-prime attribute on the prime is not allowed. So this means ACE, and the first relation will be ACE because A is identifying C as well as AE, and the second relation will be CL. So these two relations, the R2 is now further replaced with these two relations. There is no transitive dependencies in this. B identify DF, AJ identify K, and AJB identify M, but there is a transitive dependency. AB identify G, and AB also identify G, and inside this AG identify I. So this means in the AB identify G and AB identify G and then AG identify I. This means indirectly AB identify I. Remember, I is not partially dependent on A because AB identify G and then inside AG identify I. So this means I is dependent on AB. So but here G identify I. Understand? I repeat. AB identify G and AG identify H. Sorry, this is not I. AG identify H indirectly. You can see here. AG identify H, AB identify G, This means AB identify ABG, and then inside ABG, AG identify H. So H is dependent on AB. So it will become ABGH, and then you can see G identify I. How? G identify B as well as I. That is actually the union. G identify both B and I. So this means AB identify G and G identify I. So this means there is a transitive dependency. So the second relation will be GI. Now R3, R4, R6, 7, 8 and 9, 10 are in third normal form. This means R2 is no more because it is replaced with 7, 8, and R5 is no more, it is replaced with 9 and 10. So this is now in the third normal form. Hope you have enjoyed the lecture that is about normalization. I tried my best to convince you. In next lecture I will teach you about B, C and F. That is the modified normal form of the third normal form. So that is enough for today. Thank you so much.